Assalamualaikum and hi everyone. So in this video, we are going to discuss revision question for answer chapter 5 states of matter side A. Alright, so you are given limestone CaCO3 which decompose to produce solid carbon dioxide and carbon calcium oxide gas when heated at high temperature. So at 30 degrees Celsius, a volume of 107.3 milliliter of gas was collected by displacement of water with a total pressure of 1 atm. So the given vapor pressure of water at 30 degrees Celsius is 31.8 millimeter mercury. So calculate A, number of moles of carbon dioxide produced. So from balance equation, okay, CaCO3 which decompose to CaO and carbon dioxide. Since carbon dioxide in the reaction is collected over water, so the gas collected here is carbon dioxide. So we can calculate the partial pressure of H2O in atm. So given partial pressure for H2O is 31.8 millimeter mercury, so we convert to atm, divide by 760 millimeter mercury. So this is the mass, so this is the pressure of partial pressure of H2O. Okay, so P total, okay, P total is equal to PH2O plus P carbon dioxide. So the total pressure is at atmospheric pressure is 1 atm. So 1 atm minus 4.18 exponential negative 2 atm. So we have 0.958 atm. So this is the pressure of carbon dioxide. So from pressure of carbon dioxide, we are using PV is equal to nRT. So N carbon dioxide. And carbon dioxide is equal to pressure carbon dioxide times volume divided by R times T. Okay, so pressure of carbon dioxide give from P total just now, we got 0.958 atm. So the volume given is 0.1073 liter. So this one we got from the volume of gas, 107.3 milliliter. R is 0.08206 liter atm per mole per Kelvin. And then the temperature is 303.15 Kelvin. So the temperature given is 30 degrees Celsius. So convert to Kelvin. 30 temperature in Kelvin is 30 plus 273.15 Kelvin. So we have 303.15 Kelvin. So this is the temperature. So we convert into N is equal to PVRT over RT. So we have number of mole for carbon dioxide is 4.13 exponential negative 3 mole. So the mass of limestone decomposed. Calculate the mass of limestone decomposed. From balance equation, 1 mole of carbon dioxide is produced from 1 mole of calcium carbonate. So the number of mole for carbon dioxide is 4.13, which we got from part A. So the number of mole for calcium carbonate is 4.13 exponential negative 3 mole. So the mass of calcium carbonate is equal to 4.13 exponential negative 3 times 100.1. So 100.1 is the molar mass of calcium carbonate, okay, which is 40 plus 12 plus 3 times 16. Okay, which is equal to 100.1. Okay, so the mass of calcium carbonate is 0.413 grams. Alright, so for set B, based on the following data, Sketch and label the phase diagram and determine whether liquid X or solid X is denser. Explain your answer. Given melting point of pure X is 20 degrees Celsius, the boiling point of pure X is 98 degrees Celsius, and the critical point is 140 degrees Celsius and 1200 torr, while the triple point given is 38 degrees Celsius and 500 torr. So, sketch the phase diagram. Sketch and label the phase diagram. So first of all, to sketch the phase diagram, you must draw the axis, which is we have y-axis for pressure in torr and temperature in degrees Celsius for X. X-axis is temperature. Okay, so, and then we just sketch the temperature here. 500 degrees Celsius, 500 torr, 760 torr, and then 1200 torr. While for temperature is 20 degrees Celsius, 38 degrees Celsius, 98 degrees Celsius, and 140 degrees Celsius. So, the melting point of pure X is 20 degrees Celsius. So, melting point is at 1 atm. So, at 1 atm, (20 degrees Celsius). Okay, for triple point, the triple point is at 500 torr or 760 millimeter mercury and 38 degrees Celsius. So this is triple point. While the critical point is at 1200 torr and then the temperature is 140 degrees Celsius. And the temperature for boiling point is 98 degrees Celsius. So this one should be here. 98 degrees Celsius should be here. So, the graph should not start from the origin. Okay, your graph should not start from origin. And then, liquid A is denser than solid A. This is because at 1 atm, at 1 atm and 20 degrees Celsius, it is in the form of solid. Okay, and then at 38 degrees Celsius and 760, it is in the form of liquid. So, the temperature, when temperature decrease, the pressure is increased. This shows that liquid A is denser than solid A. And the melting point of A decrease with pressure. So your graph should have label for solid, liquid and gas, 1 mark. The axis and plot graph, 1 mark. And then the shape of the graph is 1 mark. Alright, so we move to question B. Determine whether propanol CH3, CH2, CH2OH or propanol CH3, CH2, CHO has higher vapor pressure at room temperature. Explain your answer. So which one has a higher vapor pressure at room temperature? So for propanol, propanol is an alcohol and then it has hydrogen bond. While propanol, the structure of propanol is C double bond O H CH3 CH2. And for propanol, CH3, CH2, CH2OH. So the intermolecular forces exist between propanol are hydrogen bond because we have OH here due to the presence of hydroxyl group, while the intermolecular force exists between propanol is dipole-dipole forces, which is only weak one-wall forces, no hydrogen bond in propanol. Thus, hydrogen bond is stronger than dipole-dipole forces. So the weak intermolecular force between propanol molecules making their molecules easier to vaporize. So easier to vaporize meaning that it has more vapor pressure. Thus, vapor pressure is higher at room temperature. So the vapor pressure of propanol is higher than the vapor pressure of propanol at room temperature. So the total mark for this question is 18 marks. Alright, so that's all. Wish you all the best. Dreams come true. Thank you.